Good morning. Here, this is the topic from the subject of physics. Topic is limitations of Newton's laws of motion. You can see, I think. So here I have written 4 points, total of 4 points. First is special theory of relativity by Albert Einstein. Second is quantum mechanics. Okay. Third is general theory of relativity. And fourth is chaos theory. And I think all the 4 terms, all the 4 points are known to you. At least to some extent it is known to you, I think. So limitations, yes, of course. Newton's laws of motion have certain limitations. It cannot be applied. You know, there are a total of 3 laws. First law of motion, second law of motion, and third law. So there are a total of 3 laws, and all the 3 laws can be applied for the problem of statics as well as for the problem of dynamics. It is known to you. And in class 11 and 12, we normally use this theory. Okay, not only in class 11 and 12, in various fields, in engineering discipline, okay, most of the works are done using this theory. Works are done means calculations are done, okay. Even the motion of airplane, motion of 4-wheelers, means motion of vehicles, motion of 2-wheelers, everything can be analyzed. Motion of all these things can be analyzed using Newton's laws of motion. Even the motion of rocket, motion of satellite, motion of planets also can be calculated using Newton's laws of motion. So you can see that Newton's laws of motion is of utmost importance. To such big things, Newton's laws can be applied, but still there is limitations. Not for all the cases Newton's laws can be applied. That's why I have noted down here 4 points total. Number 1, special theory of relativity. It was given by Einstein in 1905. Okay. So, special theory of relativity, it can be applied for high speeds, means speeds near the speed of light, okay, for high speeds as well as for low speeds. For all types of speeds, this law, means special theory of relativity, this holds good, okay. This has been proved to be correct for high velocities as well as for low velocities. But for high velocities, means velocities comparable to the velocity of light, in those cases, Newton's laws of motion cannot be applied. If you apply Newton's laws of motion in those cases, means high speed, okay, so you will get erroneous result. Okay, you will get erroneous result. So that is one limitation. For high speeds, Newton's laws of motion cannot be applied. Next comes quantum mechanics. You know, quantum mechanics, this is the mechanics for small particles, means subatomic particles. Okay, to analyze the mechanics of subatomic particles, quantum mechanics was developed, and it was developed in the year 1925, I think, 1925. And this theory, the first one, special theory of relativity, in 1905. After 20 years of this theory, this was invented. Quantum mechanics, this was discovered, not invented. This was discovered, okay? Quantum mechanics. And you know that quantum mechanics is applied for subatomic particles, means small particles. Electrons, protons, neutrons, okay? These particles. So, if you apply Newton's laws of motion for those small particles, you will not get correct result. Okay? In those cases, for subatomic particles, only one thing you can apply, that is quantum mechanics. If you apply this theory, then you will get correct result. Means computational value and the experimental values, you will see that they are matching. Okay. But if you apply Newton's laws of motion in those cases, then you will get mismatching of the results. Calculation and experiment won't match at all for subatomic particles. Next comes general theory of relativity. This was also proposed by Albert Einstein in 1915. 1915. Okay, this was in 1905. This was in 1925 and this was in 1915. Okay, general theory of relativity by Einstein. This theory is applicable for massive bodies. You can say that Earth is massive body, Sun is massive body. Yes, bigger bodies are also available in the universe. Bigger than Sun, bigger than Earth. Okay, so those are called actually massive bodies. For massive bodies, okay, means thousands of times greater than the mass of the Sun, thousands of times or millions of times greater than the mass of the Earth. Those are called massive bodies. So for massive bodies, Newton's laws cannot be applied. If you apply Newton's law, then you will get again erroneous result. Okay, results don't match. Such as when analyzing the motion of the galaxies or cluster of galaxies. In those cases, if you apply Newton's laws of motion, you will get erroneous result. Okay, those are massive bodies, galaxy or cluster of galaxies. Those are massive bodies as compared to Sun or Earth. Those are millions times or billions times greater than the size of this Sun or Earth. So if in those cases, if we apply Newton's laws of motion, results won't match at all. So in those cases where mass is so huge, mass is vast, in those cases only one theory you can apply, and that theory is general theory of relativity. Okay, general theory of relativity can be applied for those cases. Then you will see that results are matching. One more thing I want to say with that special theory of relativity, this reduces to Newton's laws of motion when velocities are low. Special theory of relativity. Okay, this is applicable both for low velocities as well as for high velocities. So for low velocities, this theory reduces to Newton's laws of motion. Again, this is applicable for massive bodies. Okay, this theory also reduces to Newton's laws of motion for small bodies like moon, sun, satellite, rocket, vehicles, etc. Okay, for all those things, general theory of relativity reduces to Newton's laws of motion or Newton's law of gravity. Okay, I should rather say Newton's laws of gravity, because this theory relates gravity. General theory of relativity. This is for speed and this is for gravity. Third one. First one for speed or velocity, and the third one is for gravity. Where gravity is low, in that case, general theory of relativity reduces to what? Newton's laws of gravitation. Here heading I have written only Newton's laws of motion. Here one more thing should be added, that is Newton's law of gravitation. Okay, and at last comes chaos theory. Chaos theory, it was emerged later, much after all these three theories. Where chaos theory is applicable? To apply Newton's laws of motion, initial condition of the bodies in motion should be known. Initial conditions means starting point. At starting point, the point from where the motion was started, at that point, kinematics, okay, kinematic values, dynamic values should be known at the starting point. And if there is any error in knowing the values, numerical values of the kinematic values or in the values of kinematics or dynamics, in those cases, what happens? Result becomes totally unpredictable. Okay, in many cases are there where a small error in the measurement of initial condition will give you drastically different result. So to deal with those cases, one theory was emerged. That theory is called chaos theory. Okay, chaos theory was emerged for that purpose. Otherwise, if you apply Newton's laws of motion in those cases where a small change in initial condition may be there is a chance that you don't know the exact value of the initial condition. Okay, in those cases, if you apply Newton's laws of motion, then you will get drastically different result. Okay, means experimental result and the theoretical result won't match. In those cases, chaos theories are applicable. In the field of physics, in the field of biology, in the field of economics, chaos theories are applied at present. Okay. So, why this theory was emerged? What is the reason? The reason is about the initial condition. Because for all the cases, we don't know initial condition exactly. Okay. Still, we need to do calculations to predict the future. Okay. In many cases, we need to assume the initial condition. We don't know the actual values of the initial condition. We need to assume. So, in those cases, Newton's theory, if you apply Newton's theory, in those cases, you will get erroneous result. Okay. Means experiment and the calculation won't match at all. In those cases, the requirement is to use a different theory, and that different theory is chaos theory. Okay. So this was all about limitations of Newton's laws of motion as well as limitations of law of gravitation. Okay. In the title I have written only Newton's laws of motion. I should rather say limitations of Newton's laws of motion. These things should be omitted. Limitations of Newton's laws. Okay. Then this will include all the three laws of motion as well as law of gravitation. Okay, this is the end of this lecture. Thank you. Thank you for watching this video.